Welcome back, everybody. This is Base and Heroes. Today we are going to talk about surface area. And to talk about surface area, we have to begin, well, making we have to refresh our ideas on area. Yeah, so here we have how to calculate the area of a triangle, how to calculate the area of a square, parallelogram, a circle, very important, we are going to see it today, yeah, and some other polygons. Then, well, some other polygons and other figures like the ellipse, sector. Okay, then what we are going to work on is we are going to begin by talking about the surface area of a prism. This one is a triangular prism, and we can tell that it has some different faces. How many faces? Well, they are 4 faces, right? One of them is blue, another one is green. So we can tell from the net, yeah, that it has 1, 2, 3, 4 faces. Yeah. And this prism, well, we are going to calculate the area of either one of the faces, and we are going to add them up. So it is a process, but if we know how to, it won't be complicated at all. So if we are calculating the surface area for a cube or a rectangular prism, now we just have to calculate the area of each one of the faces. Yeah? And we can tell that this one has 6 faces. So that is what we have to keep in mind, not to get confused on the amount of faces, and to make sure that we calculate the area of each one of the faces and add them up at the end, so we have a total surface area. Yep. So to do that, we are going to we don't need to make the net, yeah, but we just need to get an example. So let's begin with this example in which we are going to calculate the surface area for both a rectangular prism and a triangular prism. So let's begin with it. It is like this. So we are going to say we are going to calculate the surface area of this face. I mean, the area of that face, which is a polygon, is just a square. And then it says 9 times 10, right? 9 times 10. So we are going to, well, I am going to do it with the, well, just like this. 9 times 10. So we can tell it is 90. 90 what? 90 is square feet. Now, so it is like this. Now, we can tell that this is another face, which is the same size. Well, not only the same size, but the same shape, so it is congruent. So this congruent face, well, is going to make me have this result times 2. So that is one of the faces. Now I want to go not only with that face, but I want to go with all the faces. So we can go with this face. We can be super fast with this. And this one is 15 feet, yeah, we can tell, by 9 feet height. Now this one is congruent to this height, so it is 9 feet. Now 9 feet height. So how do we calculate it? Well, we are going to multiply 9 times 15. Now 9 times 15. How much is 9 times 15? So times 10 is 90. So plus 45, which is the half of it. So it says 135. 135 what? Is square feet. Again, now we say it is a square feet, and it is times 2 because we don't only have this face, but this congruent face, which is there in the back. Now, well, if you don't want to say there in the back, it might be on the left side, somehow. Then we already have that one, and now we are going to go with the one at the bottom, yeah, the one which is somehow the base of it. So it is going to be 15, yeah, 15 times 10, 15 feet by 10 feet, yeah, and we can tell that is 150. 150 is square feet, yeah. So this is a square feet, and once again it is times 2 because this area, which is 10, this is congruent, by 15 is going to be 150 square feet, but this one on top, which is somehow the ceiling of our house, barn, whatever we want to call it, is going to be just as big. Well, it's just going to have the same area. Then, we can see this over here, and we have to multiply by 2. So we have 2, 4, 6 faces of the rectangular prism. We're going to calculate now the ones of the triangular prism. And this triangular prism has something important, and is that we shall not calculate the base by the diagonal. I wanted to take this example because of it. We are not supposed to take this diagonal because it's not the height, and the formula says base times height. It doesn't say anything but base times height. So the height, if we really wanted to take this base, we will have to get the perpendicular height. I mean, the perpendicular height to the base, and we don't have it. And if it is not given in the drawing, you are not going to be able so far. You are going to be able in next grade. But the idea is that we don't have it now. So if it is not given, don't get complicated. So what are we going to do? We have a secret. That secret is this. This is showing me a right angle. Right angle means that this is perpendicular to this other, right? They both are perpendicular to each other. This one is perpendicular to the other. So I can take one of them as the base and the other one is the height. If I take this side and this side, you can tell they are perpendicular to the other, and so there is a 90-degree angle between them. And because of it, I am going to say 7 times 7. I shall not take that 10, but the 7 on the side. So side by side, which is base times height for the triangle, divided by 2. This is divided by 2. So this is 49. We can tell. This is 49 divided by 2. And how much is 49 divided by 2? 49 divided by 2 is 24.5. In this case, 24.5 is square feet, because this is area. Now we have to multiply by 2 once again, because this area of this triangle is just congruent to the area there in the back of the triangle there in the back. What are we missing? We are not going to calculate this base again, this rectangular base again, because we have already done it. We have already done it here on this step for the rectangular prism. So what we are missing is this one, which is on the side, that rectangle, and the other side, which is on the left upper side, on the upper left side, and actually they are congruent, so we can get one and multiply by 2. This is 15 by 7, isn't it? 7 on one side, 15 on the other. It is a rectangle. So what are we going to do? We are going to multiply this. So we are going to multiply 15 times 7. And how much is 15 times 7? 10 times 7 is 70, plus the half of it, which is 35. So 100 what? 105, exactly. So 105 what? A square feet. Everything is a square because it is area. We are talking about surface area, so keep it in mind. Now we just do the numbers and add them up. So let's do it. Now 90 times 2 is 180. We are going to organize it here very well. So we say 180. And all this is going to be an addition. All right. So it says 180 plus what? 180 plus 135 times 2. How much is 135 times 2? 200 what? 270. You are on fire. And 150 times 2, which is how much? 300. You said 300. It is correct. Now all of this is a square feet. We don't write the unit because we have to write it at the end. Now notice that the thing with the triangle is that we have to divide by 2 because it's a formula, but because there are two congruent faces, well, we come back to the beginning. So I prefer to do it than skipping this step and saying, hey, where did this come from? So it's 49. This will be somewhere around here. And we have 105. Now this 105 is times 2 again. Remember, it's just one side, so it is 210. 210 what? A square feet. And everything, all this, we are going to add it up. So I am going to get the spaces off, not to get confused. And so you know where it comes from. So it says, this is 0, 9. Now this is going to be 9. I am going to go like this. And this is 9. And then we have 8 plus 7, which is 15. And then 4 is 19. And then 1. So I write 0 and I carry 2. Now it says 1, 3, 6, 8. And with the 2, it will be how much? 1000. So, wow. Let's be a little better with that 1000. It will be 10, isn't it? So it says 1 plus 2 is 3. So it is 6. 6 and 2 is 8. And 2 we carried before makes it 10. So it is 1009. 1009 what? 1009 is square feet. So if we wanted to, I don't know, decorate it, paint it, do something with it, so we will have to use one. This is the number we had to keep in mind. Okay, very important. Now we have already practiced the one for prisms, and we are going to go on with something very important, which is a cylinder. How to get the surface area of a cylinder. So let's go straight on it. Now you have screenshots on it. I am giving you the PowerPoint for it. So you are going to have a lot of fun with this. Now, I am taking all these from a website which is called Math is Fun. Math is Fun is a fantastic platform in which you have all these animations, in which you have all these different exercises you can practice with. So it is absolutely fantastic. I do recommend it to you. Okay, let's go on. And it says we are now going with this. Oops, it is here. So what we are going to do is, first of all, we are going to remember how to get the circumference of a circle. Circumference is the distance around the circle. And look at this, it says, it is given as pi times diameter. D stands for diameter. And the diameter is the distance, the distance from one side of the circle to another, passing through the very center of it. I am just going to make a circle here. Well, let's say this is a circumference, and the very circle will be the inside of it. So let me do it. Let me try again. Okay, this is better. So the circle is the whole thing, inside and outside, and the circumference will be some people call it the perimeter around it. I like that definition, but anyway. So this is the circumference, the distance around it. And there is a direct relationship between that distance all around the circle and the diameter. The diameter is then that line which goes through the center from one side of the circle to another side, going by the center. If you get a line which doesn't go by the center, it's just an arc. Oh no, it's not an arc. I mean, it is a chord, right? It is a chord. And we don't want to have a chord. I mean, we could have 1,000 chords, But what we care about is the diameter. And the diameter is 2 times the radius. The radius is just half distance from, well, is actually the distance from any part of the circumference to the center of it. So the radius, your bicycle has so many radius there on the wheels, right? So there is one radius, 2, 3, 4, 5, we can have an infinity amount of radiuses, of radii, actually you call it the plural, radii. So you have the radius of it, which is the half distance of the diameter. So if you multiply 2 times radius, you have the diameter. And I explain you that because you say, if the formula is this is the circumference, why you change it like this? Why you change it now? Well, because it is now 2 times r for d. So why? Because people prefer to get the radius. It's easier actually to get the radius than to get the diameter. Why? Because imagine that you were walking this distance. You were a big circle and you have to walk. So you don't want to walk from one point to the other, but you just want to walk from the very center of the circle to the circumference. Any point of the circumference, it will be half the walk, right? Half the hike. You don't have to walk that much. So come on. And there are some other important issues about. So it is very important that we keep in mind. It is much more common to have the radius times 2 than the diameter itself, right? So the circumference, if you want to get it, is pi times the diameter. And what is pi? Pi is this. Well, if you want to calculate it there if you want to get it there in your, oh my God, because of the background, I cannot show it in my calculator. Actually, I took this picture from my calculator, and this is the pi symbol, which goes there on just above the exponential key, right? Is in most calculators is like that. However, if you don't know it, you can get the number 3.14 1592. And there is an infinity amount of numbers, which are decimals, but we don't have to go there. We can remember only this. We can make a rounding of it and say that this is the value of pi. If your calculator doesn't have it, because it's not exactly a very it's a very traditional calculator. So, well, you can use this number, 3.1416, right? However, what is pi? Furthermore than the value of it, what is pi? Pi is a relationship, the relationship between the diameter and the circumference. That connection is pi. And that's why it is so important, right? So that's why it appears to calculate the circumference. So once again, 2 times the radius times pi. Why do they place the 2 apart from the radius? Well, because they want to get the letters and no number in between, right? So because it is multiplication, you can organize it in any way and it doesn't matter, right? So this is it. We are going to get an example on how to calculate the circumference of a circle. So we have this example here. We have 5 centimeters, right? So what we know is that we need to multiply 5, which is the centimeters, which is the radius, by pi. So we are going to say, and we have to multiply by 2. So times 2 is 10, because that is the diameter. So we only have to replace in the formula. This is the formula, 2 times pi times r for radius. And when we replace numbers, we say, well, 5, once again there. Now we substitute 5 for the r for radius. And then we have 2 times 5, once again. This is a long process to get the 10. But, well, you knew it from the beginning. And you say, well, I have to get 10 times pi. So the very exact answer is given in terms of pi. Terms of pi means I don't do the multiplication for the value of it. Why? Because it has an infinity amount of decimals. Whatever I shorten from it, my calculator has, 100 decimals for the value of pi. But anyway, it is an approximation because it is an infinity amount of decimals. So because it is so long, we say that the very exact answer is 10, the calculation, the diameter in this case, times pi. Centimeters, because it's a distance, The circumference, once again, this is the circle. The circumference is the distance around the circle. This distance around the circle, once again, might be somehow described as the perimeter of it. So it is given in centimeters, in meters, kilometers. It depends on the unit you need to work with. However, if you want to multiply it, well, you can multiply pi by 10. And because it is 3.14, 1416, or well, just to round it up. So we could say that we are going to multiply that, and notice that now it says it is an approximation. So it is approximately 31.4 centimeters, right? And that is basically the circumference in our example. Okay? Now we are going to move on with the area of the circle. And let's remember that the area of a circle, well, is all the shaded region inside the circle itself. If we cut it this like a pizza and we place the pizza like this, the pizza slices like this, we will get something approximated to a parallelogram. However, if we cut smaller slices, these curves will be smaller too. And finally, if we had an incredibly small amount, an incredibly big amount of small pieces, of small slices, then everything will become more straight. Yeah? And the more straight, the more it approximates to a parallelogram. And we know how to calculate the area of a parallelogram, right? Which is side by side. And because it is side by side, then, well, we can calculate the area of a circle, just saying that, well, we do some calculations, but we want to go straight with the formula. And the formula is this: pi times radius to the power of 2. Yeah? So this is the area. Notice that is different from the circumference, as the circumference is pi times 2 times the radius, right? Well, we wrote it like 2 times pi times r. Yeah? This one, the area, is with radius to the power of 2. Yeah? For the circumference is 2 times the radius. Yeah? Keep it in mind, it's very important to keep the difference of it. So let's get an example. Yeah? Now we have the diameter, and the diameter is 10 centimeters. And they say, well, just read the formula. The formula is pi times radius to the power of 2. So notice they are not giving us the radius because it's just a half, so we don't have to do any calculation, but we know it is 5 centimeters. So it says, we do the replacement, so 5 to the power of 2 is 25. In terms of pi, the exact answer is 25 pi. 25 pi centimeters, right? So this will be the very exact answer. However, we want to multiply by 3.14 or by all the decimals which appear there in our calculator, and we just press pi times 25, and it will be, in this case, 78 and this amount of decimals, which is approximately to 78.5 square centimeters. And this time, Jesus Christ, keep it in mind, is squared because we are talking about area. Okay? That's it. So now we move on. And we move on with calculating the surface area of a cylinder. Now, why a cylinder goes like this? Well, we are going to take a look at this beautiful animation, which is available in mathwarehouse.com. I took it from there, and there are other fantastic animations. If you explore this site, you're going to be amazed with the incredibly beautiful possibilities. So you can tell that the area of the cylinder is given as the, look at this, you see, when you open the cylinder, this curved face is actually a rectangle. And then you have to know the height of it. And what else do you need to know? Well, you need to know the radius. Why? Why the radius? Why the radius for a rectangle? Well, because when you open this width happens to be the circumference of the circle. You see the connection? It's beautiful. It's so lovely. Yeah, look at this. So you open this curved face. And so you can tell that this distance, which is the circumference, yeah, is actually the width of our rectangle, this distance. So we can calculate it just knowing the radius of our circle. Yeah. So when we do the numbers, oh my God, what did I do? Yeah. So when we do the numbers, we are going to be able to tell that, oh Jesus Christ, I just want to pause it and I cannot. So let's wait for this. Okay, so I couldn't make it. Then, look, I am going to place it here. Finally, I made it. Okay. Then the radius, is then the formula 2 times pi times radius, as the width of our rectangle. The rectangle, which is the curved face of our cylinder. And what about the top face and the bottom face? Well, they are going to be the area of a circle. And the area of a circle is pi times radius to the power of 2. And guess what? Because there is a top face with a circle and a bottom face with a circle, we have to add them up because they are two faces. Yeah, there is an upper lead and there is a bottom lead. Yeah, if you want to cover it. Yeah, so remember mathwarehouse.com. Yeah, there you will find beautiful animations like this. So keeping this in mind, we say this. Look at this. This part of the formula is the rectangle. Now, this is surface area. We are calculating the surface area of a cylinder. Now, so we are calculating this rectangle, which is there in the formula. Why? Because we get the height of it times the width. It means we just calculate side by side. Beautiful, huh? For us to know the width of it, this width, we need to know the diameter or the radius of our circumference, our circle actually. Then the other part of the formula, says actually this is area of a circle, pi times radius to the power of 2. And it is times 2 because there are two. Let me get it. There are two faces which are circles and they are congruent. So we have to calculate one, multiply by 2. And so you got it? So far so good. I know it's a lot of information, and you know what? This is beautiful. Furthermore, we can calculate, with keeping all these ideas in mind, we can calculate volume of the cylinder, right? Which is coming soon, but so far let's concentrate on surface area. So let's get an example here. It is always better to work with an example. So here we are going to say that we have the radius 3 centimeters and the height 5 centimeters, right? So we get the formula. Once again, this part is a rectangle, this part is the two circles, the upper one, the bottom one, and then we just have to replace on the values. So it says 2 times pi, times 3, which is 3. Which is this 3 coming from? Well, this 3 is the 3 centimeters, which is the radius. It says radius. So, and what about the 5? Well, the 5 is the height. And the height is here, so we multiply by 5. times 2 is the part of formula. Now 2 times pi times radius to the power of 2. Radius. Yeah, you got it? So we just replace the values here, and so we say 3 times 2 is 6. 6 times 5 is 30. 30 pi. Yep. It is multiplication. Whatever we change the factors, whatever the way we change the factors, it is not going to change the product, right? The product is going to be the same. 30 pi. And here we say 3 to the power of 2 is 9, exactly. 9, 3 times 3. Yep. 3 to the power of 2 is 9. 9 times 2 is 18. 18 pi. So it is an addition. So you say 48 pi square centimeters, and we got the surface area of a cylinder. And everybody claps, and everybody understands, and everybody gets 10 in the exam. And I am super happy, and I am a proud teacher because everybody gets 10. All right? That's what we are looking for. No, we want not only to get 10, but we want to learn. All right? So kids, now we want to get, this is the exact answer. Yeah, remember, this is the very exact answer. We can calculate, we can do the calculation. Well, we can do the calculation by multiplying 3.1416 or pressing that key there in the calculator and having so many more decimals, multiplied by 48 in our example. And so we will have an approximation, an approximated answer in square centimeters, which is actually more commonly used. Okay? So kids, look at this. Do I have something else? Well, I have these. Look, I am going to show you why the calculation of a cylinder is just basically the same than the calculation of a prism. Yeah? How come they are close to each other? Well, surface area, we are getting one face, added to another face, and we have to calculate them all, right? So for volume, it is just the same, right? We have to do the calculations. Now, look at this. The thing is, we have here triangular prism, and if the height changes, well, all the calculation changes, right? Depending on how high it is, and depending whether it is oblique. Yeah. So let's say that this is just right. And then here we have another prism, which is a rectangular prism. It can be a cube, right? A cuboid. So it's a rectangular prism. But the more places I have, the more faces I have, the more it looks like what? The more it looks like what? Check it out. The more it approximates to a cylinder. That's it. So we have to calculate how high it is, and we have to calculate the face over here on top, the face over here on the base, and that's it. We have to add them up. So there is a complete connection there. So we could get some other examples there on this wonderful page of Math is Fun. So thank you very much, kids. I hope you have learned. I hope you have understood. I know you are going to have excellent grades. Keep in mind that this could be decimals. This could be fractions. So practice with all of them. Thank you so much. I send you a big hug. See you later, alligator.